Hi, today we are going to solve this integral. And actually, it doesn't look very easy. First of all, I think we need to use substitution. We should substitute our logarithm of x with t. So, if we have logarithm of x equals to t, then we can write exponent of logarithm of x, and it will be, of course, exponent of t. And we know that from here we obtain x. We can use actually this rule, a to the power of logarithm. Here will be x, and it will be equal to exponent of t. So next we need to substitute our dx. Dx gives us d exponent t, which gives us exponent, dt. And, well, we have x, we have logarithm, so I think that's all. And now we can use our substitution and obtain such result. Logarithm gives us t, then dx gives us exponent of t dt, then we have x, and right here our exponent, then will be square root, here will be 6 plus 4 t minus t squared, and our exponents are gone. And as a result, we will have this integral t dt divided by square root of 6 plus 4t minus t squared. So what we should do now? First of all, let's write differential of this line. 6 plus 4t minus t squared. This differential gives us derivative of 6 plus 4t minus t squared dt. And we can calculate this derivative and obtain 4 minus 2t dt. So, actually, in our numerator, we want to have 4 minus 2t. How can we obtain it here? So, I write it like this. So, first of all, we need to multiply our numerator and, of course, denominator by minus 2. So, we will obtain this situation. Minus 1 divided by 2 goes in front of our integral. Then, here we will have minus 2t. Minus 2t, and we can see that all this line equals to t actually, and of course dt, and here of course will be our denominator. So we have now minus 2t. Then we need to add and to subtract 4 in our numerator. So let's do it. minus 1 divided by 2, then 4 minus 2t, 4 we write plus 4, then we need to write minus 4 because we shouldn't change our integral. And here will be dt, and of course our denominator remains the same. So now we have two integral. We can divide this line by this and this by this and obtain two integrals. First will be 1 divided by 2 integral 4 minus 2t divided by 6 plus 4t minus t squared, and of course square root, and dt here. Then we have minus 4 divided by this line. Minus multiplied by minus gives us plus. 4 divided by 2 gives us 2 integrals of, here will be 1, so we can write here dt, and our denominator remains also the same. So now we split this integral into two parts. And we know that 4 minus 2t dt equals to differential of this line. So we can write it here, integral of differential 6 plus 4t minus t squared, and here we will square root of the same line. So then we have this integral, and to calculate this integral we need to remember a formula for arcsin. So when we have an integral of dx and in denominator there is a square root of a squared minus x squared, this integral equals to arcsin of x divided by a, of course, plus constant. So here I want to use this formula, but to use this formula I want to find a squared and x maybe minus something or plus something squared. So let's do it. Let's see what we can do. Here will be 2, of course. In our square root, if I write 10 minus from here, then t squared minus 4t plus 4. It will be the same denominator. So we can write 10 minus t squared minus, and minus gives us plus 4t minus 4, and 10 minus 4 gives us 6, and also we will have minus t squared and 4t. So this line and this line are the same. But why we did it? Why we wanted to obtain our line looking like this? Well, because now we want to use formula, well, where I can write it, this formula, maybe here, a plus b minus. Here we have minus squared. A squared minus 2ab plus b squared. So we can see that this is the formula. So let's use it. Here I, well, rewrite our line just a little bit. Square root in denominator gives us the power of minus 1 divided by 2 d 6 plus 4t minus t squared. It's the same. So plus 2 integral. Here will be dt divided by, well, let's write it like this. Square root of 10 to the power of 2 minus, let's see what we have here, t minus what? Minus 2. Because of 2 squared gives us 4. So t minus 2 will be here squared. So this line gives us this one. And of course, don't forget about square root. Also, we can put minus 2 here because a changed nothing. So now we can calculate our integral, this and this. So first we have minus 1 divided by 2, then minus 1 divided by 2 plus 1 gives us 1 divided by 2, so I think I will write square root 6 plus 4t minus t squared, and also we need to divide this line by 1 divided by 2, so 2 goes up, and we have minus square root, and then plus 2, and let's see. In our formula, a squared minus x squared. But we have no x, but we have t minus 2. And a is square root of 10. So we can write here arcsin of x divided by a. So here will be not x divided by a, but here will be t minus 2 divided by square root of 10. And that's all, plus constant. And now we need to substitute our t's with functions of x's. So let's do it. Minus square root 6 plus 4 t's logarithm, 4 logarithm of x minus logarithm of x squared plus 2 arcsin of logarithm of x minus 2 divided by square root of 10 plus constant, of course, our constant from real numbers. So this line is the final result for calculation of our integral.